we're going to be dealing with the law of sines. Now, in a triangle, notice this is not a right triangle. Okay, this is a, could be a scalene, obtuse, not a right triangle here. It says for any ABC with side lengths A, B, and C. So notice that the little a, little b, little c, those are the lengths of the sides. The capital A, capital B, and capital C, those are the angle measures. Also notice that capital A, the angle A, is across from the side length A. Capital C, the angle C, is across from the side that's length C. And capital B, angle B, is across from the side that's length B. Now for the law of sines, you can use the law of sines to solve a triangle if you are given either ASA, an angle, a side, and an angle with the side between the two angles, or AAS, angle, angle, side. Okay, so where you have the angles, and a side that's not included. You can also use it if you have two sides and a not included angle. Okay, so those are the three cases when you might use sine. What the law of sines says is that these are equal to one another. If you take the angle, the sine of the angle, over the length of the side across from it, it's equal to another angle, the sine of another angle in that triangle over the side across from it. It's just equal to the sine of the final angle in the triangle over the length of the side across from it. We're going to look at an example to kind of show how this works. Okay, it wants me to find the length of NP. Again, this is not a right triangle, so we cannot use the Pythagorean theorem. We can't use the trigonometric ratios for this. We are going to use the law of sines. Okay, were we given one of our cases, notice we have an angle, and a non-included side. Okay, so we have angle, angle, non-included side, so we can use the law of sines. The way you set it up, okay, so we're trying to find NP, which is the distance from here to here, the length of this side. We may also call that our M. Okay, we set up the law of sines, so we have an angle here, sine of our angle, which was 32 degrees, over the length of the side across the figure from it, which is 46. That should equal the sine of another angle. Notice our sines are on top. We do know another angle, the sine of the 84-degree angle, over the length of the side across from it in the triangle. Now notice that's our NP that we're working for. I'm just going to call it X because it's easier to write X than NP every time. Okay? And then we want to solve this. So how do you solve when you have a fraction equal to a fraction? Well, we cross multiply. That gives me X times the sine of 32 is equal to 46 times the sine of 84. I'm not done yet because X is not by itself. So what do I need to do next? Well, I have X times the sine of 32. The opposite of multiplying by the sine of 32 is to divide by the sine of 32. So I divide there. Whatever you do to one side, you have to do to the other. And there is my answer. X, my missing side, is equal to 46 times the sine of 84 divided by the sine of 32. And we just have to use our calculator and find out what that number is. Now you may want to, as you're going through this, you may want to use parentheses. Okay, so I'm going to do the top first. I'm going to put parentheses. Okay, I'm going to put the sine of 48 first. So I put 84 and then push sine. I'm going to multiply that by 46. Okay, and I'm going to close my parentheses. So notice I did the sine of 84 times 46. Okay, I'm going to take that and divide it by the sine of 32. So I put 32 sine. I'm not done. I have to push equals. And when I do push equals, I get 86.33. I'm not sure what it said to round to the nearest tenth. So 86.3. You want to be very careful when you're entering these things into your calculator. go one at a time. If you want, you can calculate each thing individually and write it down. The problem is the more rounding you do, the further you'll get from the exact answer. That's the only issue. Okay, so again, how did we enter that in our calculator? Well, I used parentheses here, and I did the sine of 84, so I put 84 sine, and then times 46, and then I closed my parenthesis. That was my whole top. Then I divided by the sine of 32. So I put 32 sine and pushed equals, and I had my answer. Okay, this one wants me to find the length of AC. So AC right here, there's my x value that I'm looking for. Can I use the law of sines? This is not a right triangle, okay? And I have angle, side, angle. Two angles and the side between them. Was that one I could use the law of sines for? Let's go back. Yep, angle, side, angle. And you may want to write down in your notes which kinds you can use. Okay, so I'm going to use the law of sines. So notice I have, here's an angle. So I'm going to write down the sine of that angle. So you do the sine of the angle over the length of the side across from it. Now the length of the side across from it is the one I'm looking for. That's my x. Should equal the sine of another angle in the triangle. Look, there's another angle. So the sine of 44 over the length of the side across from that angle. Uh-oh, that didn't work. I don't know the length of that side. Okay, so when something like this happens, then you have to assess and go, what did I do wrong? Well, notice the side that I have here that they gave me. In order to use it, I would have to know this angle. Can I find that angle? Yes, I can. How? Well, the angles in a triangle add up to be 180 degrees. So I'm going to backpedal a little bit. Okay, so now I know I don't want to use the 44-degree angle because I don't know the side across from it. Okay, so now I back up and I say, okay, we're going to clear that out. I'll come back to this in a minute after I know the measure of this angle. Again, how do I find the measure? Well, angle A plus the 67-degree angle plus the 44-degree angle, all together, they should be 180. Why? Because there's a total of 180 degrees in every triangle, and those are my three angles. I add the 67 and the 44 to get 111, and then I subtract 111 from both sides to find out how many degrees are left for that last angle, and it's 69. So this is a 69-degree angle. All right, so I hit a little bump, but that's okay. I can come right back and keep on going. So here's the side that I knew. I needed the angle across from it, and now I have that angle. It's 69. So the sine of an angle, 69, over the length of the side across from it, which is 18. Now I am all set up, and I can solve this equation. Okay, so what do? We cross multiply. That gives me x times the sine of 69 equals 18 times the sine of 67. And I highly suggest putting the number in front when you're multiplying so you don't get it mixed up. I still need to solve this for x, and right now x is being multiplied by 69. So I do the opposite of multiplying by the sine of 69, and I divide by sine 69. Whatever you do on one side, you have to do on the other. Then I'm going to take out my calculator and find my answer. Again, be very careful when you're calculating. Order makes a big difference. I need to calculate 18 times the sine of 67 divided by the sine of 69. So I'm going to start doing the sine of 67 in parentheses. So parentheses, 67 sine times 18, and then I'm going to put the end parentheses. So parentheses, sine of 67 times 18. Divide that by the sine of 69. So I put divide 69 sine. And your calculator may be different if it's handheld, but that's how it works for mine. Make sure you push equals. And I get x equals 17.7.